My only apprehension, fairly slight that it is that these capacitors aren't the right way round. So I've got the amplifier, the main amplifier, which is over there, hiding behind there, switched on, and the gain is just on about 10%. We'll go back down here. Now I'll go back a little bit so you can see the smoke. I mean, you can see it working okay. I'm going to slam the mousetrap shut, and I've got it connected to my iTunes music. There isn't iTunes, it's Music B, and this should just fairly instantly come to life. So let's see. Stand back. Right, we better not leave it on there too long. The music police could be listening, and I'm sure they are. If they can make a few pennies out of me putting copyright music on, I'm sure they're going to. Right, well, it basically amplifies, and it was coming out of both channels, and I don't see any smoke. Let's just see if anything's getting warm. Nope, they're stone cold. Heat sinks, stone cold. I think we may have a winner here, Houston. Well, it's been running now for about half an hour and still no explosions, and nothing's even lukewarm. The heat sinks, you're just about conscious that they are slightly warmer than ambient. But I've done a quick few measurements of voltages and things, and with a 15-0-15 transformer, we're getting 20 volts plus and minus on the smoothing capacitors, which means that the regulators, which regulate down to 12 volts, are doing perfectly good job. Now, you can run this off a transformer of 12-0-12. I've tried it, in fact, and the same thing. The heat sinks then remain stone cold, because you may be, well, I did guess that this wouldn't draw much current, because these type of op amps just don't. But it's very hard to measure the DC consumption without removing links and things like that. So I've measured the AC here, and each rail draws about 10 milliamps. When you first turn it on, the input current zooms up, well, zoom isn't really the word, leaps up to 100 milliamps, and within 2 seconds, after these capacitors are obviously charged up, it drops down to 10 milliamps and has stayed there ever since. So the actual power consumption of the low voltage side would be obviously somewhat less, because the regulators are burning up a bit of power. So I would think the whole circuit's probably drawing about 8 milliamps DC, and probably a large proportion of that is that LED, which ironically is not burningly bright as they usually are, so someone's thought about it a little bit. An interesting thing, when you turn the power off, you can still run this for 25 seconds before it all goes distorted and horrible as the rails drop, because there's obviously so much capacitance here, and well, all over the place, that, and the current consumption's so low, you could actually, well, 25 seconds is a long time to run without any power. Needless to say, this little transformer, which you can almost see, runs, again, it's just got the magnetizing current on it, which makes it just fractionally warm. I've started doing some frequency response checks, and what you're looking at here is the output on a yellow channel, and the blue channel is the input. And I've synchronized them up at 1 kilohertz so they're flat, and I'm superimposing them on top of each other. Now, I wanted to show you how low the frequency response would go, and this is as low as I can accurately measure. If you look on here, that's 3 cycles, or 3 hertz if you prefer. It's absolutely flat. I mean, it is basically a DC amplifier anyway, so you'd expect it to be. But I can't go any lower because I lose sync on the scope, and I can't scope. If I go down that's 2 hertz. Let's change the time base. Yeah, I've lost it now. Silly scope won't sync. Here we are at the other extreme of the frequency range. This is 20 kilohertz, and again, it's just flat. And this is getting boring. This is 50 kilohertz, and as you can see, it's still flat. It's not half a dB down or quarter of a dB down, it's still flat. There we are at 50 kilohertz. After that, it starts to roll slowly, and it's 1 dB down at 100k. Note also there is no phase shift on there. I've got the traces superimposed, and we're triggered on the input signal. So if there was phase shift, you would see one trace sliding towards the right or to the left. So effectively from 3 hertz, which is the limits of my measurements, up to 50k, there is no discernible phase shift. I've been listening to this amplifier now quite comprehensively over the last 2 or 3 days, and I've actually found something which has surprised me. Now, I think I've mentioned previously that this uses the OPA2277 Pre, which is not strictly an audio amplifier. Now, I have to clarify that by saying obviously any amplifier that will amplify in the audio spectrum is an audio amplifier, and this is no exception. But unlike the 5532 and amplifiers or op-amps of that type, most of the specifications on those lead towards audiophile performance, where distortion is quoted as a silly number of noughts, and it's got a nice sound, to quote some people. Whereas this OPA, it hardly mentions any of the audiophile specifications in the specifications. It's got an appropriately low distortion within the audio bandwidth, but other than that, it quotes all sorts of things that aren't strictly relevant to an audio amplifier. So I bought this kit knowing that this was the case, and I'd be interested to see how a high performance non-audiophile op-amp performs. And it's more of an interesting conclusion than the difference between so-called audiophile op-amps. This sounds harsh. I need to clarify that by saying you're not going to listen to it within sort of a few minutes and think, oh, that's dreadful. But unlike most audiophile preamps, this does have a sound, and from that point of view I found it very disappointing, but not surprising, because they don't claim any particular audio performance from it. But it has a noticeably harsh sound in the upper mid-range, leaning towards, no, I can't simulate it, I won't even try, but it does have that kind of sound. Now, an interesting test, this has 3 of those op-amps in it, And when you put it in a circuit like I've shown you before that just uses one chip, it doesn't sound that bad. And I can't believe it's the circuit that makes it sound bad, because as I've said many times, if you give it the right voltages and the right impedances in and out, it won't. The external circuitry has very little, if any, what's the word? Effect on the sound. So I did another test. I took out the 5532 on those little tiny boards that I've reviewed many times and substituted one of these OPA chips, and it actually sounds okay. The harshness vanishes. Now, is it because I've got 3 of these in circuit in this board, and the slight harshness that it creates is amplified 3 times? That's the thing. I don't know the answer to that. I thought I'd show you this because I think it's very remarkable. That is a 2 Hertz square wave coming out of the Discrete preamp. And just to show you that it's true, if I swing over to the meter without stopping the camera, you can see this is an AC coupled meter, and you can see the meter swinging around because obviously it can't resolve such a low frequency. Isn't that amazing? Now, if you think that was amazing, this is more amazing. That's a 1 Hertz square wave. And if we look at the meter, we look at the scope. Now, it won't sync, unfortunately. I've messed around with the sync and the frequency is too low. That's one way to do it. Look at that for a square wave at 1 Hertz going through the preamp. I just think that I've never seen anything like it, to be honest. Try doing that with a valve amplifier at any frequency. And here again, pretty good, is a 10 kilohertz square wave, as you can see displayed on the scope there. I'm going to go up a little bit higher and see where it starts to look a bit sad. Let's go up to 20k. That's 20k. That's not a bad square wave. All the fluff on there is the scope, digital scopes. If I could afford an analog scope, I would throw this in the bin straight away. Out of curiosity, let's just go up a bit more. We'll go up to 30k. Oops, well, we've gone a bit further than I thought. That's 40 kilohertz. Again, not a bad square wave. Now those figures are all for this discrete preamp board, which I've shown you previously. But I have at last discovered what these small pots are for. It's a very, very fine adjustment for DC offset. And if you put the scope on the 10 millivolt range DC, as they arrive from the factory, the pots are in the center. But the only thing I can find that it influences is DC offset, and it's microamps. It's literally minuscule from one end. And this is why before, when I said I didn't know what the pot did, I couldn't see that it was making any difference. It doesn't make any difference to frequency, square wave performance, gain, or anything like that. So I thought, I'll just have a look at it. I set the scope to DC, and the line is well down into the noise, but it does give you a very accurate center point, and the pot is not in the center. In fact, both of the preamp boards have a different setting. But I've now got 0, or as 0 as I can measure, DC offset, and it doesn't drift either. Well, I'm sorry this video's been jumping around quite a bit. It's mainly because I've spent the last 4 or 5 days messing around with this board and little chips, and I've really come to a conclusion that I'm surprised. Firstly, let me just get my notes because I've written some things down. The OPA2277 Pre, to be precise. I don't think it's that good for audio use. We're talking of fine limits here, so you're not going to use one, providing it's not the ultimate in criticalness. Is that a word? I think so. It's okay as an op-amp, but as for its use in audio, I have to say with 3 of them on this board, the sound is harsh. Now, taken out of context, everybody would think, oh, rubbish, don't want that. But it's not like that, because all these op amps that I've shown you in the past, and you've probably got experience of your own, none of them are actually rubbish. All of them sound at least pretty good. And in many cases, if you haven't got this comparison to make between the different op amps, they are pretty well all the same. But this particular one, the OPA2277, particularly when there's 3 in use on one board, has a definite harshness to the sound, predominantly upper mid-range, and it can be quite easy. Even my wife noticed it. Now, I was surprised because I asked her to think what she thought about it, and she came up with that conclusion within about a minute of listening to both boards. So let's talk about this board initially. Now, its claim to fame is there's millions of capacitors on it, and in all honesty, they are largely superfluous to the board's operation, because any of these chips, providing you give it the right voltages and sensibly decouple it, they're going to work fine. They've got very good rejection for ripple from the power supply, so you don't need 1,000,000 microfarad to make it hum free or noise free. But this has gone to theoretical limits. Every capacitor electrolytic is bypassed by a miler. I think they're probably miler. And in all honesty, it makes 0 difference to the sound and the measurements. Now, it's fair enough, if you've got oscillation or something, you may need to hang more capacitors on it. But I've not found with any of the experiments I've done, the chips become unstable, oscillate, ring, or anything like that. So you're paying a lot for this board for basically gain. And if you want a variable preamp that is a precision, I must admit the precision resistors on here keep the channels in balance to almost, you can't say there's 1 dB difference. They're pretty well bang on. You can superimpose the waveforms and you can't see any difference. And it does give a fair degree of gain in the maximum positioning. Heat sinks on these regulators are a complete waste of time, because the whole thing, I think I remember telling you, it draws 10 milliamps from the AC side. So and you're only dropping 4 or 5 volts at that sort, less than that current. So these are, you can just feel on the heatsink that it's slightly above ambient temperature. So you don't need heatsinks. You could bolt the regulators straight to the board, which does have a pad to dissipate that tiny little bit of heat. So you could save money there. I've commented already about the capacitors, but what was the other thing? Oh yes, the little switches here are not very good quality, and you sometimes have to wiggle them about to make a good contact to get the required gain, because I've been messing around with them a lot, and that's not what you do with these sort of switches. You normally set them and then that's the end of the thing, and they'd probably be fine for that. But I have to say, for what this cost, I can see why it costs what it does, but in terms of these things, it's no better. And the fact that it uses the OPA, it actually does have a sound. Now, that goes against my preachings, because I've always said a preamp that has a sound is no good. And because of the harshness on this, I've actually tried, by the way, changing these to 3055s. No, not 3055s. 5532s, and it sounds better. So basically this OPA is a thumbs down. If you happen to buy this kit, take out the chips and put them somewhere and replace them with the 5532s, and it sounds better. I do have to say, not just because of the price, but these, will it focus? Maybe. They cost next to nothing and have a 5532, and if all you want is gain, you will not find a better module. It's DC coupled, minimal components on it, and it comes with some connection leads as well, which is quite useful. And overall, that I don't think you're going to significantly better that. But saying that, overall, the little indiscreet, I think I need some coffee. The little discrete preamp that uses lots of power does measure exceedingly well, and I've just shown you some figures on here, and I have to say that at the moment I'm like that, whether to use that board or this one. And incidentally, the other board that I'm using is this one with it plugged into here and the chip removed. So I'm actually leaning towards the discrete preamp. I'm not totally convinced it sounds better than the 5532, but it does measure better. And it's mainly things that you can't hear anyway. So as to which one I would recommend overall, I don't know what to say, because this costs nothing. I mean, it's just so cheap and ridiculous, but the discrete one costs 10-20 times as much, and it does measure slightly better, but it only measures slightly better out of passband, 40 kilohertz, 50 kilohertz. So clearly no one can hear that, especially someone with 71-year-old ear holes. But whether it's the placebo effect, I'm tending to lean towards that with this being a very, very close second, if it's second at all. Right, I'm just going to finish off with some figures on the discrete preamp that I've done, because I didn't do this terribly long before, but it's completely flat, no dB down, but completely flat from 3 Hertz to 29 kilohertz. Ruler flat. And it's 1 dB down at 90 kilohertz and 2 dB down at 160 kilohertz. I'm giving you these numbers purely because I've done them and I wanted to share them with you. I'm not suggesting that only being 2 dB down at 160 kilohertz is going to make any impact on your ears or anything. But as you've seen from the numbers, it does give a very, very good square wave at virtually all frequencies. You need a bit more gain, go and buy one of these. I mean, it's just silly cheap, and I can't believe you won't like it. But if you do, throw it away. You've lost less than the price of a coffee. So that puts it into perspective, doesn't it?